So now let's apply the trig identities. Let theta be an acute angle such that tan of theta is 1/3. Find the value of A, cotangent of theta, and B, secant of theta using trigonometric identities. So really this is what we did before, but now we're using a different trig identity. So we know that we have tangent of theta, and let's write that cotangent of theta, we can figure that out pretty quickly. We know that cotangent of theta is 1 over tangent of theta, so that's just the reciprocal, right? So we know that tangent of, or cotangent of theta is just 3. So that one's done, that one's fast. Now we have to figure out secant of theta. So let's go ahead and use the tangent of theta is 1/3. So we're going to use 1 plus tangent squared of theta equals secant squared of theta. So we know that tangent theta is 1/3, so 1 plus 1/3 squared equals secant squared of theta. And then, so this is 1 plus 1/9 equals secant squared of theta, and we can change it to 9 over 9. So this is 10 over 9 equals secant squared of theta, square root both sides. So now we know that secant of theta equals square root of 10 over 3. So that is B, and then we figured out A pretty quickly. So try the next example below. Let theta be an acute angle such that theta equals 2, and then find the value of cotangent of theta and secant of theta. All right, we've tried this out. You can immediately find cotangent of theta. It's just a reciprocal, so it's 1/2. Secant of theta, when you solve for it, plug it into the trig identity, you would get secant of theta equals square root of 5. So we're going to use trig identity to transform the left side of the equation into the right side. So this is when theta is between 0 and pi over 2. So we're given sine of theta, cosecant of theta equals 1. So this is where knowing our reciprocal, quotient, and Pythagorean identities come in handy. So we know sine of theta times cosecant of theta. We want to make it equal 1. So this is not where you're adding or subtracting. This is not an equality property. You're just trying to get this left side to be equal to 1. So you can't add, subtract, multiply, or divide it to the other side, to both sides. Now what we can do is just change things. So we know that sine of theta, that's fine. So cosecant of theta, that is 1 over sine of theta. And notice that they cancel out, so therefore 1 equals 1. So that is true. Letter B, so we have cosecant of theta plus cotangent of theta times cosecant of theta minus cotangent of theta equals 1. Now I see that there's a plus and minus here, and we're multiplying their conjugates, and so that is actually pretty helpful. So let's multiply this together. What we get is cosecant squared of theta, and this is a plus and minus. So we know that we would get cotangent squared of theta equals 1. Now that reminds me of something. That reminds me of 1 plus cotangent squared of theta equals cosecant squared of theta. Now if I manipulate this by subtracting cotangent squared of theta, here, I notice that I get 1 equals cosecant squared of theta minus cotangent squared of theta, which is this. So now I can say that this whole part on the left turns into 1, and that does equal 1, which is true. So I want you to be careful with the trig identities. They have to be squared in order for it to change, okay? So the cosecant squared of theta minus cotangent squared of theta, that is squared. Same as sine squared of theta plus cosine squared of theta equals 1. Notice they are squared. And then the 1 plus tangent squared of theta equals secant squared of theta. Those are squared, okay? Because I know sometimes students see sine of theta, cosine theta, and they think that equals 1, and that's not exactly true. So be careful with that. Try this last example here. Use a trig identity to transform the left side of the equation into the right side of the equation. Okay, if you try this out, you would, on the left side with A, notice that I converted tan to sine over cosine. Cosecant is 1 over sine. The sines cancel, which makes it 1 over cosine. So this is secant theta equals secant theta. Then on the right, you multiply, so it's cosine squared of theta minus 1 equals cotangent squared of theta. We're trying to make it equal cotangent squared of theta. Then what I did is at the bottom I said, okay, that reminds me of 1 plus cotangent squared of theta equals cosecant squared of theta. If I subtract 1 from both sides, I notice that cosecant squared of theta minus 1, which is what I have here, does equal cotangent squared of theta. And so it is true. I made it look like the right side. I do want you to show me which one you are using to show full work on that. And so I hope this helps out.